Hi guys. All right, I'm back. This is part 3. This is the third video of the Unit 8 exam review. So here we're starting off with this problem. As you sit on the beach of a tropical island, you decide to utilize your expansive knowledge of physics to calculate the speed of the waves you are watching. So you observe a wave with 3 crests and 3 troughs pass in 1 second. All right, so we have 3 crests, 3 troughs, and they're passing all in 1 second. Sounds like they just gave us some information. All right. The wave travels at an average of 18 meters in 3 seconds. Use your physics skills to calculate the wavelength. All right. So we should use our velocity is equal to wavelength times frequency. But first, let's set up a list of knowns and unknowns. Do we know velocity? Well, not quite, but we could calculate it here. 18 meters divided by 3 seconds, right? Distance over time, so 18 meters divided by 3 seconds. That'll give us 6 meters every second. So that's our velocity. What about frequency? Well, frequency is the number of cycles that occur in 1 second. And here you go, 3. 3 crests, 3 troughs. So if we were to draw that out just so you could visualize it, that's 1 crest, 1 trough, 2 crests, 2 troughs, I'm sorry. So we have 1, 2, 3, 3 crests and 3 troughs. That is 3 wavelengths. So we have 3 cycles occurring in 1 second. That's our frequency. It's 3 hertz. Ouch. Okay, here we go. We have a list of knowns and unknowns. We just don't know the wavelength. That's a question mark. So let's set this up to solve for wavelength. How would we do that? Well, here's our starting equation. We would just divide f on both sides because we know f and we know v and we want to know wavelength. So it will look like this. Right? Okay, now plug and chug. What's our velocity? Yes, very good. 6 meters for every second, 6 meters per second. And what about frequency? Yep, 3 hertz. All right, guys. Here we go. Wavelength is 2 meters. Yay! There you go. All right. All of the waves in the image below occur in the same amount of time and in the same medium. Okay. Rank the waves least to greatest according to the characteristics below. All right. So the amount of time that's occurring here. Let's just go with t is equal to 1 second because this will be really easy when we're trying to do frequency, and frequency is one of the problems here. All right. Okay. First, let's talk about wavelength. This is a pretty easy one. We're going to go least to greatest, so let's do small to big. The smallest wavelength is here on B. And then what's kind of after B? Well, here we go. This one right here, C. And then we're going to go with A. That's a little bit bigger than C. And then that just leaves us with D. D is that big. That one has the largest wavelength. Okay? All right, now frequency. What is frequency again? Well, let me just remind you. Frequency is the number of cycles or the number of oscillations that occur in 1 second. If we have determined that all of these waves occur in 1 second, the only thing we have to do is count their wavelengths, and that will help us put the order of frequency from least to greatest. So how many wavelengths are occurring in A? 1, 2, 3, and following the Jack Gay method, since we start and end with the crest, that means we're 1/2 less than what we have here. So since we have 3 crests, and it starts and ends with a crest, that means we have 2.5 wavelengths, so 2.5 hertz. And let's do this again. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And since we start and end with a crest, we have 12, but it's 1/2 less. So the frequency for wave B is 11.5 hertz. And then for C, we're starting with a trough. So let's count the troughs. 1, 2, 3, 4, 5. And we end and start and end with the same, so it's 1/2 less of 5. 1, 2, 3, 4, 5. So before 0.5, everything's in halves. And this one's pretty easy. We have, well, actually, this is half of a wavelength. 0.5. Right? Yeah. That's not a complete wavelength. Okay. So let's go from least to greatest. So these are all the numbers for the frequency. So 0.5 is definitely smaller than any of these. So D has the smallest frequency. And then we go to A, which has 2.5. And then we go to C, which is 4.5. So I'm sorry, I was going to write 4.5. C. And then B. B has the greatest frequency. DACB. All right, now that we have all of these values up here, we can easily calculate the period. What is period? Period is 1 over the frequency. Now, there's another way to look at this and do this, except I'm just going to go through and, do the 1 over 2.5. And then I get 0.4 seconds. And then 1 over 11.5, and we get, I'll write it right here, 0.09, I'm rounding seconds, and then we get 1 over 4.5, and it's 0.2. We'll just go 0.22 seconds. If you're doing this on your calculator, you'll see what I'm talking about. And then we have 1 over 0.5, and that's 2 seconds. So what is this telling us? It's telling us the period. And what is the period? The period is the amount of time, or the number of seconds it takes for one cycle to occur. So it takes 0.4 seconds for wave A, right, for one wavelength to occur. And for B, it takes 0.09 seconds for one wavelength to occur. Okay, so there you go. B is our smallest. It takes the least amount of time for one wavelength to occur. And I mean, that's obvious, right? Look at how close they don't have much distance to go. And then from 0.09, I would say that 0.22 is the next step up. So that would give us C. And then we have 0.4 seconds, which would give us A. And then D will take the most amount of time. It will take 2 seconds for one complete wavelength to pass. All right, there you go. Good job. All right, here we go. What is the wavelength of a sound wave traveling through the air if it has a frequency of 120 hertz? So you should know the velocity of a sound wave traveling through the air, and we determined that at the beginning of this review. I think it might have been in part 1. And we know that the velocity of sound in air is 340 meters per second. And this gives us the frequency. We're almost there to solve for wavelength. We're going to use our wave equation, set it up to solve for wavelength. What would that look like? V over F. So plug and chug. 340 over 120, and then you go to your calculator and you go beep, 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 boop. 340 divided by 120, and you end up with a wavelength that is 2.83 meters. I know it's a big issue with, well, how do I round? What do I round to? Typically, I'm like saying to the 10th place or to the 100th place. I'll be sure to put that on our quiz this time around, okay? All right, so that's your answer for this problem. All right, next one. If a light wave has a wavelength of 0.00000065 meters, what is the frequency? If the frequencies of light waves range from 400 trillion hertz to 800 trillion hertz on the color light spectrum, what color is this light most likely to be, a red or a violet light wave? All right, so let's first figure out what the frequency is. All right, this we're going to use our wave equation, right? And we're solving for frequency, so that means it's going to look like V is equal to, start over. F is equal to v over wavelength. And what is the velocity for what is the speed of light? It is 3.0 times 10 to the power of 8 meters per every second. That's a 10 right there, guys. Sorry. And then we know what our wavelength is because it told us right here. 0.1234565 meters. Why do I make these numbers? Because this is actually real. I tried my best to make it as real to what is going on with light waves as possible. So this is actual numbers, okay? If the frequency of a light wave ranges from, okay, and we'll do this part after we get the answer to the frequency. So how do we do this? Well, I would first put in your calculator 300 million. That's what I'm doing right now. And divide that by 0.000065. And you end up with 4.6 times 10 to the power of 13. That is about 460 trillion, okay? 460 trillion. Well, if our light waves range is 400 trillion to 800 trillion, well, 460 trillion is at the lower end. And you should know that red is on the smaller end and violet is on the larger end. So violet would be closer to about 800 trillion and red is about 400 trillion. So the color that we would have is red. All right, guys, I'm going to end there. And then, yes, I'm going to make a 4th video. OMG. All right, guys.